read the test corrections?
No. I'll get to do usually test corrections are the low grading priority for me usually. Okay. That's all I can say.
You number 4.
Yep. Number 4. Percent problem. Harry and Jack raised roses and petunias in their garden. If 15% of the flowers were roses, and there were 120 roses, how many flowers were there in all? So let's come up with an English sentence.
Times. Well, I guess F equals.
Right, 15% of the flowers, that's of the total, is 120. 15% of the total is 120. We want to know the total. Because 15% of them are roses, and there are 120 roses. So, to find the total, what are we going to do?
15 over 100 times F over 1 equals 1.5.
15 over 100, right, times F, or whatever variable you want to use, over 1 is, yeah, I'm going to just write that as a fraction too. Then what do I do?
15F.
Nope. Before that, there's something I can do to make my life easier.
Simplify.
Simplify.
3 over 20.
Yes, 3 over 20. All right, so now I get what?
3F over 20.
Equals, yeah.
Multiply by 20.
Yep, we can do that. So we get 3F equals, what's 120 times 20? Notice, what's 12 times 2?
Well, 240.
No,
2,400.
yeah, because you've got 12 times 2, and then there's 2 extra zeros, 2,400.
And then divide by 3.
Yep,
It's going to be 800.
yep,
What I thought 120.
yes. And the roses are 15% of the total.
So out of 15, then like F over 1 equals 120.
Because 15% of the total number of flowers, 15% of the flowers are roses. Yes?
I almost said 120.
Yeah, there are 120 roses. So 120 is 15% of the total.
Matthew, we have school today.
I'm going to give him another like 3 minutes. And then before people start showing up, we'll be back. So yeah, so they're 15% of the total, they tell you, are roses, and there are 120 roses. So 15% of that total is 120. Next one that you want to go over, or another question about that one.
No.
Nobody wants to go over any more?
Oh,
You had a whole list.
I thought you said
You had a litany of problems that you wanted to ask me about before class.
Trying to choose one. Let's go. I don't know. Can we go with 17?
17. All right.
Because like I don't know. I just don't know how to start off. I mean,
Okay,
I don't know how to
so
start off.
yes. So 17. We've got, what do we call this here? This kind of thing here.
Substitution.
What do we call this thing when we've got multiple equations with the curly bracket on the left?
They're but they're having it. It means they're having it at the same time.
Yes, it's called it's a 3-word phrase. The second one is of. A blank of blank. A system of equations.
System of
So to solve these, they tell us to use substitution. How to
like set of numbers that equal that variable.
Right, so we're going to take an equation where we have one of our variables by itself. So we find some other way to write that, and then we can plug that into the other equation, and now we'll have an equation that only has one variable, and we'll be able to get a solution. Matthew, would you just move your desk forward a bit, like 2 feet? Maybe. Yeah, that's great. It's just a little more Orderly. All right, so which one of these equations, notice we don't have, in neither of these equations do we have a variable by itself.
No.
So, are we just going to give up?
Yes.
It's hopeless. No! What can we do?
You could
Just erase the whole problem.
add 3y to 7.
To,
Isolate x.
yeah, so the first equation, we can rearrange that one pretty easily to get x by itself. Anytime we're substituting, we want to rearrange one of the equations to get one of the variables by itself. It doesn't matter which one we rearrange, and it doesn't matter which variable we isolate. So whatever's easiest. Here, it's pretty easy to isolate either x or y in the first, x in the first one or y in the second one, but let's do x in the first one. So how can we rearrange this first equation to get x by itself? Add
3y.
add 3y to
7. Negative
to
7.
both sides. Yes, x minus 3y equals negative 7. So we add 3y to both sides. Morning, Ant, please get in dress code. We have visitors coming today. I got homework so I can check it. Yes. All right, so what are we going to get when we rearrange that equation?
My bad, Mr. O. I had to walk and I didn't bring my crutches, so I had to stop.
Your crutches? Oh boy.
I
Okay.
thought I was okay, because I could walk.
You gotta walk to school.
Yeah, my parents are working. I mean,
All right.
I live down the street.
So, what are we going to get when we rearrange this equation?
You're going to get x equals
X
negative
negative
4y.
7 plus y. 3y.
Yes, or yeah, x equals 3y minus 7, we could say. Because we're adding 3y to both sides.
Yeah.
Yes, does everyone see how we got that? How we rearranged that? These two equations are equivalent to each other. Okay, now we've got one of the variables by itself. What can we do?
You can so plug it into the bottom equation.
Right, we're going to substitute this into the second equation because this is the first equation rearranged. So how are we going to rewrite that second equation?
D3 parentheses 3y minus 7 parentheses plus y equals negative 1.
Yes. All I did was I rewrote that equation with what difference?
Oh, you plugged in very.
Okay, why don't you come sit here?
Are you?
Why don't you come sit here? Or somewhere more central. That's far away.
Okay.
Yeah. Wait, where is Elon's spot? Now come be more central. As much as I
You.
we just rearranged it, but instead of writing x, what do we write instead of x?
Why?
No.
Wait, what? Oh, the variable. Or not the variable.
3 times 3y.
The
Instead of x, here we wrote what?
3y minus 7.
Thank you, 3y minus 7. Why am I allowed to do that?
Because that's what x equals.
Because we found out that x equals that. Okay, we're always allowed to substitute things that equal other things. So now what am I going to do to solve this?
9y
9y
minus 21
minus 21.
plus y
Equals
equals negative 1.
All right, now what?
Then you do like
10y minus 21 equals negative
and then plus
Yeah, what you said.
21.
At this point, this should be mechanical to you.
10y equals 20. Or yeah, and then
That should be very automatic to you. You get to this point, you combine your like terms. 10y minus 21 is negative 1. Then we add 21 to both sides. 10y is 20, y is 2. Am I done now?
No.
No. Because I not only need to solve for y, I also need to
Solve for x.
solve for x. How do I solve for x now?
X equals 3 times 2
Yep.
minus 7.
Yep.
So x equals negative 1.
X is negative 1. All that we do is we just take that value of y and plug it in. We're allowed to do that because we found y equals 2. Now, how do I write my answer?
Parentheses, negative 1, comma 2.
Yes, negative 1 comma 2 in parentheses.
That's it.
Mr. O.
Yes.
You have to do my homework.
Oh yeah, let me check that.
Why did you move all the way over there?
Thank you. So listen, when you have a system of equations to solve, Shh. We cannot come up with a single solution for an equation that has multiple variables. You just can't do it. It doesn't work. You can only find a single solution if you can find some way to rearrange things so that you only have one variable. That's what we did here with this substitution. We found, here's a way we can rewrite x. Then, if I rewrite x like this, now I can rewrite this second equation without using x at all. I only have y. Now I've got one variable, and I can come up with a solution for it. Hold on. You guys have anything you want to ask about?
Let me fix the problem.
You definitely can do that one, but
Wait, what's today like? So a bunch of people just come and peek in class.
we have our open house. So there's, I think, 17 different families registered to come this morning. Mr. Telke is going to be giving them tours around the building, popping into classes during periods 1, 2, and 3, just to give them an idea of what the school's like so they can see a normal day. The whole school. I'm not sure what. There are more families looking at certain grades than others, but I'm not sure. So.
Can you?
You may or you may not have visitors in your classes. You guys probably not going to have to do anything other than just be attentive and respectful.
Smiley.
What if they come while Mr. Washington? No. Yeah. Mr. Washington.
Right. Next one you want to go over? Number 20.
Yes.
All right, number 20.
What was the answer to that?
We're going to graph number 20.
We are, pretty sure.
Well, that's what they tell us to do. That's what the directions say.
That's true.
Graph these equations on a rectangular coordinate system. Okay. Now, the equation that they give us in number 20 is 4 plus 3x minus y equals 0. We could use this. In general, when we're graphing an equation, it's going to be easy to do if we can get one of the variables, preferably y, by itself. So we could do it like this, but let's rearrange it first to get y by itself. It's going to be pretty easy, right? Yeah, just add y to both sides. I'm going to get what?
Y plus 3x equals y.
Yeah, or y equals 4 plus 3x. All right, now what do I do? Once I get to that,
Make the box thing.
yeah, I make my chart. All right, what am I going to do now?
Plug in x at the top, y at the bottom.
Yep.
0.
Okay, 0 is always a good option. 1 is always a good option.
Bro, actually, it's not revolution, man.
And I always like to use
Negative 1?
-1. These are my default 3.
Mr. O'Fallon.
Because then you get a positive, you get a negative, and you get 0. But the arithmetic isn't going to be too difficult with these.
What?
Be careful. Please pay attention. If you got x being divided by something, it might be easier to pick different values. If x is being divided by 3 or something, you might want to pick x values that are evenly divisible by 3. But here, we're not dividing x, so we can just use 0, 1, and -1. So if x is 0, what's y going to be?
No, 4.
4, yes, because 3 times 0 is 0 plus 4. If x is 1, what's the y going to be?
5.
What?
No,
Wait,
it's
yeah,
4
multiplying by-
plus 3x.
Oh, 3x. Yeah.
3x, so you got 3 plus 4.
Yeah.
And what if x is -1? What's y going to be? Right, because it's 4 plus -3. Now, what do I do?
Plug it in the graph.
Now I'm going to graph it. My coordinate plane, on my Cartesian plane, x, y, there's the origin. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, where's my first point going to be?
Up 4.
Yeah, I just go up 4 because 0. I don't go left or right. I go up 4. 1, 2, 3, 4. Where's my next point going to be?
Over 1.
Yeah, over 1 and up 7. And my last point,
Left 1 up.
left 1 and up 1. All right, now I've got my 3 points. Look, they're in a straight line. That's a good sign. It's good to label this. You don't have to, or really, that's right, 3x plus 4. You don't have to label it.
Do we get points taken off?
If you don't label it, no. It's just a good habit to be in.
This is not clear.
What?
You,
Well, there's only one equation you're graphing here. So if you don't label it, it's pretty obvious which equation it is. But if you have multiple equations you're graphing on the same graph, you know, if I were going to graph these two this system of equations on one graph, then I should label them.
Mr. O,
Yes,
can you repeat the answers to 10 and 11, like the true or false?
yes, 10 and 11.
I thought it was
10A is true, B false. 11, A false, B true, C false, D true.
I knew it all.
Yep.
What's the next test?
The next test will be, let's see, after 64. So we're doing 62 today. So we'll do 63 on Wednesday, 64 on Thursday. So maybe Friday, probably Friday.
Okay.
I'm sorry? No, we skipped 60.
We need to skip 63.
Sorry?
We need to skip 63.
Why?
You did 29.
Actually, we're going to skip 64 probably. No, 63 is a really important one. Say it again.
29.
29. Yes. The perimeter. So you've got the rectangle down below, and you've got the 2 semicircles on top. The rectangle, those are easy. You've got 24, 12 on the right, and 12 on the left. So that's 48. And then the semicircles, you've got 2 semicircles. We're only measuring the outside bit of those. How do we find the outside measurement of a semicircle?
Square. R square.
What measurement is this? The perimeter of a circle, or a semicircle in this case. What do we call that? What do we call the perimeter of a circle?
Circumference.
Circumference. What's our formula for the circumference of the circle?
Oh, I think it's 2 pi r.
2 pi r, or pi times diameter, but 2 pi r.
2 pi r divided by 2.
Right, so here these are, so it's 2 pi r normally, but we need half the circumference because they're semicircles, so it's 2 pi r divided by 2. However, how many of them are there?
6. Oh, I thought you
How many semicircles are there?
2.
2.
There are 2. So really, we should just multiply all this by 2. If we do 2 pi r, we'll get the perimeter of both of them. It's like one circle that's been cut and opened up like this. All right, so
So it's 12.
it's 12 because the radius is 6. 2 pi 6 is 12 pi. And then we add that to the 48. 48 plus 12 pi. And then what's the unit? The unit is inches. Yeah, so anytime you've got a complicated shape like that, whether it's area or perimeter, just break it down into smaller chunks. And pick them separately. Yes?
Wasn't 62 in the calculator?
No, you don't need a calculator. We're not going to bother with the calculator stuff.
Oh, he told you no.
Okay, please don't.
Bro.
Other questions about 61, homework? Last call about any of those. If you got 10 and 11 right, that's a good sign. Also 8 and 9. 8, 9, 10, 11, that's stuff we've been doing recently.
I thought we skipped 9.
What was it?
Yeah, we'll get
8,
17.
no, 8A is integers, rationals, and reals. And 8B is irrationals and reals. Or really, you could just say reals for B. You don't need to say irrational.
I never repeat the number.
It's because it's an irrational number. That's how. It's a weird thing, but it just is. Part of what's really strange about pi is that pi isn't something that was just invented by mathematicians. Pi describes circles, which are things that exist. You see a circle, that number pi describes it. Like that's a number that comes from
I was never made to be
the physical universe. I'm sorry?
defined. I was never made to be.
Yeah, that's right. Pi was never made to be defined.
Yeah, I think it's
Not that it's true. I said
Number-
I was never made to be defined.
Oh, there are 10 students in The class, the 6 students scored 80, the other 4 scored 90, the overall average. So, we've got, how do we do overall average? Or how do we do average in general?
You add them all up and then divide.
Add them all up and then divide by what?
By how many numbers you added up.
By how many things you added up. So here, what are we going to divide by? How many students are there total?
There are,
Yeah, there are 10 students. So we know we're going to divide it by 10. Now we want to add up all of their scores. How do we add up all of their scores?
you add,
But they don't tell us all the scores.
oh.
Well, you multiply by the number, by the two numbers that you.
Right, so the first 6 averaged what? 80. So if they averaged 80,
Where do you guys at? 80?
then the total of their scores is 6 times 80. Because 80, we got the first 6.
Oh, you know, great.
The first 6, the way you find the average, the way we found the average was adding up all their scores and then dividing by 6. They got 80. So if we want to know this number, the total of all their scores, we just multiply both sides by 6. So 6 times 80, plus then what did the other 4 get? They averaged what?
90.
90. That's how we do it.
So 480,
So we get 480 plus,
360 divided by 10.
yup, which is going to give us what? What's 480 plus 360?
840.
840 over 10,
84.
84. There you go. There's your answer. 84%.
I was one off. I put 85.
So, well,
Randomly.
85 is what you would have gotten if you just averaged 80 and 90. But you have to be careful because with these ones, one way you can check your answer is, think about it. Okay, so if the same number of students got 80 and 90, then the average would be 85. It would be right in the middle. But notice, slightly more students are in the group that averaged 80, so it should be a little bit closer to 80 than to 90. And so that's a way that I can look at that answer and say, that answer makes sense. Yes. I'm sorry? This is why it's important to be here on time, so I don't have to do this multiple times.
Shut up.
Number 1
Put your mask back on.
is 273.
I'm afraid.
All right, any other questions about problem set 61? Last call?
No.
Okay, turn to lesson 62 on page 252. We're talking a bit more about square roots. Yay, square roots!
No.
I'm so glad we're talking about square roots again. This is where I am making my favorite thing. Yay, man! Square roots, what's a square root?
It's experts.
Sort of.
Opposite.
Oh, square root. Oh.
If I ask for the square root of 16, what am I asking?
4.
Okay, the answer is 4, but why? Why?
What times itself equals 16?
Right, it's the opposite of squaring. The square root of something means what number squared equals that number. It's the opposite of squaring something. So we want to know what number times itself is going to give us 16. And the answer is what?
4.
4. Well, it's a little bit more complicated than that. 4 times 4 is 16, yes? There's another possibility which we might have. Generally, yeah, what's the other thing? There's actually another number that we can square that'll give us 16.
2. Wait.
Yeah.
2 to the 4th.
No, another number that we can square that'll give us 16. The 4 squared gives us 16.
Negative.
But there's something else that we can square.
Negative 4.
Negative 4 squared will give us 16 because negative 4 times negative 4 will give us positive 16. Now, normally when I'm asking for square roots, I mean the positive square root. But you should be aware that technically negative 4 is the square root there. This is more important when you get to things like pre-calculus and calculus. So sometimes the way that you see these written is if we have an equation like this. and they want the solution of this equation. Now, you see this equation? What degree is this equation? It's a second degree equation. How can you tell it's a second degree equation? Right, the highest degree, the highest exponent on a variable is squared. We had a special name for first degree equations. What do we call them?
Linear.
Linear equations, yes. Because they're, when you graph them, there'll be a line. A second degree equation, they also have a special name, which you should know. These are called quadratic equations. Quadratic equations. Which means, roughly means square equations.
Wait, is this supposed to be warm today or tomorrow?
Tomorrow, I think, because today it's supposed to be really warm. So when we have a quadratic equation, we will usually have two different solutions. The way we could write the answer to this equation, x squared is 4, is we can write x is equal to positive or negative 2. And that's the way we write it, a positive sign above a negative sign. Positive or negative 2. There are two different answers. The other way you could write it is like this. X equals 2 or negative 2. Notice that's not an ordered pair because I didn't put parentheses around it. It's just saying there are two different answers. Please put that away. Please put the jacket away.
What is you?
I keep telling you to wear warmer clothes to school.
Well, that has nothing to do with being warm.
What?
Bro.
Why don't you do it?
He would. He wants to. He wants to.
I love that.
Then why do you want him to do it, bro?
Sometimes, if I don't use that sign, if I don't use this sign, just assume that I mean the positive root. So if I ask you, the square root of 16, just give me 4. However, sometimes you'll see equations written like this, and they give you an example here, example 62.6. Let's do that together. Negative 2 squared plus, parentheses, negative 3 parentheses, squared, plus or minus the square root of 4.
What the heck?
So you'll get
4 plus 9.
negative,
No.
negative 4
Thank you. Negative 4 plus
plus 9,
9
plus or minus
2
2, comma, negative 2.
well, you don't need to say 2 comma negative 2 because the plus or minus already means plus 2 or minus 2. So this equation, because of the plus or minus, is going to have two different solutions. What are the two different solutions?
-3.
Because it's 5 plus or minus 2.
Oh,
7.
So it could be either 5 plus 2, 7, or it could be 5 minus 2, 3.
oh.
That's all. It's not something we're going to do a whole lot of this year, but that's just the case. We talked already about cube roots, how cube roots are a little bit different. Because when you have a cube root, like the cube root of negative 27, what's the cube root of negative 27?
3, negative 3, negative 3, negative 3.
Sorry?
Cube.
What's the cube root of negative 27?
Negative.
Negative 3. What about positive 3?
Yeah, that's what he said.
What about positive 3?
No, because you'll be like 3 times 3 times 3, and you'll get a positive.
Right, when you have cube, when we have cube roots, there's only going to be one solution there. And the same thing with fifth roots. If it's an even.
No, what does it need to do that?
All right. We're going to be talking more about mostly square roots. A lot of numbers don't have even square roots. What numbers have even square roots? What are our perfect squares up to, I don't know, 14 or so?
4.
What are perfect squares? Look, they actually give it to you on page 254.
4.
4 is, well, let's start from the beginning. Before 4. No. What's the first perfect square? Yeah, it's 1, because 1 squared gives us 1. What about 2 squared?
4,
3 squared?
2.
9,
4 squared?
16,
5 squared?
25,
6 squared?
36,
7 squared?
49,
8 squared?
64,
9 squared?
81,
10 squared?
100.
11 squared?
121,
12 squared?
144,
13 squared?
132, I think.
169. 14 squared?
Lower.
All the way.
14 squared?
196.
196. 15 squared?
I was about to say, this is
You're
a
looking at
paper, bro. I was like, what?
225.
16 squared?
256.
17 squared?
281.
18 squared? 19 squared?
361.
And 20 squared?
400.
Alright, now you don't need to know all these off the top of your head, but you should know up to about 15. You should know up to 15. Perfect squares up to 15 are good to know. So now all of these you should have.
I know up to 12.
Okay, so then you got 3 to learn.
Yes.
That's all. Red list already. Learn up to 15. 13 squared is 169. 14 squared is 196. And 15 squared is 225. Now,
This is bullying.
notice that there are large gaps between these, what we call perfect squares. So for example, if I ask you to tell me roughly how big the square root of 10 is, give me an estimate. How big is the square root of 10? Approximately.
Square root 10.
Square root of 10, not 10 squared, square root of 10.
Oh. Dang.
What?
Bro.
Bro.
Oh my god.
Okay, so let me put this a little differently.
Oh, what is
Oh, square root 10.
What's the square root of 4?
2,
Is 2. What's the square root of 9?
3,
3. What's the square root of 16?
4.
Okay. The square root of 10,
that? 3 points.
Is
how do you know it's 3 point something?
Because
It's between 3 and
It's
4.
like-
Because 10 is between
3.
9 and 16. So we can say that the square root of 10 is somewhere between 3 and 4. It's
that's
more
not even
than
right?
It's more than 3 and it's less than 4. Usually the way that they ask it here is they say, what 2 integers is the square root of 10 between? It's between 3 and 4.
Will they ever ask, like, what 2 integers are the square root of 16 between?
No. They'll only do that if it's not a perfect square. So if I say, and notice also it's going to be closer to 3. Because it's a lot closer to 9. What if I say the square of 40? What 2 integers is that between? Square root of 40.
That is between.
6 and 7.
It's between 6 and 7. What about the square root of 300?
Between
Between
17 and 18.
17.
Between 17 and 18, the square root of 6.
Between 2 and 3.
Between 2 and 3. You don't have to calculate these out. Some of the problems, and I think you'll be skipping all of them, they say use a calculator. We're not going to bother using a calculator for square roots. If you do use a calculator to find these, you'll see that, in fact, that's true. The square roots of these numbers are between these other 2. You can calculate out square roots by hand to multiple decimal places. It's really annoying, but we're not going to do it in this class.
How far can you go off the top of your head with exponents? I mean,
Perfect squares.
past 20.
That's as far as I can go.
What?
That's kind of far.
I mean, there are like other random ones, like 100 squared is 10,000, but that's easy.
Do you know?
What?
Do you know the square root?
The square root of 21?
No, sorry.
No, I can't go beyond 20.
The square root of 21.
All right. Questions, comments, concerns?
No. I'm gonna write that down.
All right, it'd be good to write some of this stuff down. All right, the following for homework. 62. Let's expect to have a test on Friday. Let's expect to have test 15 Friday.
Goodness, I don't think so. And we have a test on this.
It's possible that could change.
You might have a
What? Guy?
What?
Yes.
Yeah, why would you do it?
Page 62, except for the, less than 62, except for numbers 2, 4, 5. 8. Please stop talking. 2, 4, 5, 8, 11, 13, 15. 2, 4, 5, 8, 11, 13, 15, 18, 24, 26, and 29. You can skip a lot today. Please use the remaining time to get some of that done. I'll pass out sheets.
Can I pay you like $1 for a pen?
No, but I will give you a pencil. I'll give you a speed.
Yeah, hey,
I need a pen for
That's
Mr.
not
Bostic.
Hey, teachers, they just won't accept.
you want
Mr. Bostic won't let me take a quiz without a pen.
We need a pen specifically.
We're having a quiz.
Bye.
And you
You
guys
said
do
maybe.
Spanish or history?
Oh,
If I don't have a pen for